Calculate terms in sequences by using recursive formulas. So we just did explicit formula. So let's actually write that down. So the explicit formula we did yesterday. Okay. And that is to find the nth term. Okay. So if you see something, it might not say find the explicit formula. It might say find the nth term. That's what the explicit formula is. So nth meaning any term. That is what we were just doing. A sub n equals the first term times r to the power of n minus 1. So that is nowhere in the notes, but we're going to be using that. So what we're doing today is the recursive formula, which will look a little bit different, and it's for finding some different things. We're also going to bring in the arithmetic sequences, which is if you add or subtract the same number, so it's common difference versus common ratio. That would represent a linear relationship. And then also geometric sequences. So the explicit formula that I wrote up here allows you to find any term of a sequence by using the formula written in terms of n. Okay, so we've already been doing that. What a recursive formula does is allows you to find the nth term of a sequence by performing operations to one or more of the preceding terms. So this is not going to give you as much information, but you can still use the formula multiple times. But you're going to have to use it again multiple times. Okay. So it's just applied differently. All right, so this is an example of a recursive formula right here. So we're going to find the first 5 terms of a sequence. The information we know is our first term is 7, so we only need to find 4 more technically. Okay, so we're going to have to find 5 terms. Our first one is 7 already. Okay, so we need to find the next 4. The recursive formula is to help us find the next 4. Okay. In this case, so our nth term is going to be a sub n minus 1, and I'll explain what that does, minus 9 if n is greater than or equal to 2. So we're starting with the second term is what it's telling you. Now it's always going to say this because you're going to have the first term, you're going to start finding the second one. Okay, so this is just kind of a side note. But on some of them, we're going to have to write these formulas in a little bit. So you'll have to tack this on to the end. Okay. So that just means we're starting with the second term after this information. Okay. Now what we're going to be doing, so starting with your second term, we're going to be using that formula. So second term means the n value is what?
Greater than or equal to 2.
Well, the second term is 2. Third term would be 3. Fourth term would be 4. Okay, so using that formula, okay, so we already have 7. So for our second term, so this is our first term, second, third, fourth, fifth. So those are all the n values under there. Okay, so it's just applied a little bit differently. Find our second term, plug 2 in where n is. So we have a sub 2 minus 1 minus 9. Now what's 2 minus 1? 1. Okay, so what this is saying is the second term is the first term right before it minus 9. What is the first term?
7.
7. So that's why you need that information. So 7 gets plugged in here. Okay. So we have the second term is that first term minus 9. So the recursive formula, what it does, it brings in the term before the term you're solving for to help you apply your common ratio or common difference. So what is 7 minus 9?
-2.
So the second term is -2. Okay. So this will be our answer up here. But we're going to have to find it using this.
So
But you have to do the terms in order because you need to know the one right before it because of this -1. Okay. So if it's not fully clicking yet, just wait. We're going to do. Okay. So now if I want to find the third term, that means I plug 3 in where n is. So it's a sub 3 minus 1 minus 9. 3 minus 1 is 2. Okay. So this is saying second term minus 9. We already just found the second term. What is it? -2. So you work your way forward by using the one you just found. So you do have to go in a particular order. So the second term we found was -2. So it's telling you the preceding term minus 9 would be your next term. So what's -2 minus 9? Negative 11. Now, if you notice the pattern, you're just subtracting 9 from the previous one. So could you speed that up a little bit?
Yeah.
Okay. So now I'm going to take negative 11 minus 9.
Negative 20.
Negative 20. Minus 9.
Negative 29.
Negative 29. Okay. So yes, you have permission to do that. I should see at least where you're getting the first one from. But then once you establish your pattern to it, then yes. Recursive means you're using the previous term to find the next term, which we have done before, just not specifically using this formula. So you will always be given the first one so that you can find the next one and the next one and the next one. Okay. So this is your answer, those 5. Now, could we have plugged in 4 and 5 and get the same answers? Yes. But once you notice what the pattern is, feel free to apply it. Okay, yeah.
So do you want us to do like the A3 equals A3 minus 1, 2? Or once we get that first A2, 1, we don't have to do it again?
I want to say at least once
Okay, we don't have to
for the second term, if not twice. You can do all of them. But at least want to see where you're getting the numbers from. So I can just make sure you understand that. If not, I'm going to make everybody do all 4. Okay, so I would say at least 1, if not 2. If not 4. Okay. All right, but I'll be lenient on that. But that is how recursive ones work. Now, because this was subtracting 9 each time, this is an arithmetic sequence. So we did those in module 4 last semester. Okay. We only spent 1 day on it. It was pretty basic. It was with all our linear stuff. But it's because of that adding and subtracting. All right. We're going to do the same thing, just different sequence. So we're finding again, first 5 terms. So this will be our answer up here. Your first term is 5. So you'll always have that information. Now we have a different type of formula. Again, this is a recursive because you're finding the next term using the previous. Okay. Now again, this is just telling you where to start with. So start with the second term, then go to the third, and move on. So our formula looks a little bit different this time. So we have, so let's find our second term. So it's 3a sub 2 minus 1. So this becomes what? Bless you. Okay, so 3 times our first term. The first term is 5. Okay, so if you need to use parentheses, you do that too. It's 3 times the first term. So that would be 3 times our number up here, 5. And 3 times 5?
15.
15. Okay. I'm gonna do one more, at least, if not all of them. So if I find the third term, I do 3 times the term 3 minus 1, which would be which term? So 3 minus 1 is 2. It's 3 times the second term. Second term is 15. 3 times 15? 45.
Oh.
Okay. If you notice here, it is 3 times the previous term. You can show me it once, and then you can apply it. But I better see it at least once. If I just see you write that down, write the sequence, I'm not giving you squat for that. Which question?
How did it go from 9 to 5 on the first one?
That's not 9, that's A1.
Oh.
Anything else? So what's our fourth term? 135. 45 times 3. Okay. Would be 135 times 3 again. 405. So, if you're not 100%, then you need to do all 4, all the way. But as soon as you establish that pattern, then you can finish it. Okay. So at least I want to see one application of the formula then once you figure out what's going on, yes, you can just multiply by 3. Is that fair?
Yes.
Yeah.
The other option is I'm making you write all of it. Okay. Now, the last one was arithmetic because we're adding and subtracting. This one would be geometric because you're multiplying each time, which is what we did yesterday. Let's just apply a little bit differently. So, those recursive formulas, depending on what type, because we're going to do the opposite, we're going to write the formula now. Okay, Kinsey, what's your question?
For the last two times, do we know if we're subtracting and multiplying based on, like, how it'll say 3a? That's when we're multiplying.
So it'd be 3 times the previous term is what that's telling you, and then this one up here is previous term minus 9. So it will be evident there, but I want to see your application of the formula at least once, just to make sure you understand how it works. Okay. Any other question on the first two? Now we're going to do the opposite. You're going to be given a sequence, you need to write the formula. So this is why you need to understand kind of how it works. So you're going to have to first figure out whether it's arithmetic or geometric. Arithmetic will be adding or subtracting the same number. So that's what's called a common difference. Okay, and the way that that's applied, we did use this formula previously. Well, a version of it. We used the explicit one. So a sub n equals previous term, is what that's telling you, plus or minus, technically, your common difference. So D is common difference, so that's if you're adding or subtracting the same number, is what that pattern is. Geometric will be multiplying or dividing, which is technically multiplying by that fraction we talked about yesterday. So you do need to see which one is occurring before you decide which one you're writing. Now the explicit formula we wrote at the top was a1 times r raised to the n minus 1 power. This one is entirely different. Now will I give you all the formulas on your test? Yes, but you need to know which one you're using. So this one's recursive. Okay. Now keep note of step 3 down here. Okay. You have to write it the way example 1 and 2 were given to you. So you have to write the first term is this, your formula, and you will have to write n has to be greater than or equal to 2. Okay. So you always need this information, and you tack that on the end. It's just a technicality, really. Okay. But we're coming up with the formula.
Will it always be n is greater than or equal to 2, or
Yes.
is it sometimes a different number?
It's always that because it's saying n is the second term and beyond, is what it's telling you. Because if we did the first term, you would have 1 minus 1, and there's no such thing as a 0 term, really.
Gotcha.
Okay, so it's always starting at 2. So you can assume that that's always going to be there. It's never going to be n is greater than or equal to 3. It's always 2. Okay. So that's what this means, that the first term in the domain for n. So if you want to make a note to yourself, it's always n is greater than or equal to 2. Just tack that on with your answers, okay? Just a technicality, really, but it is included in your answers. So when you are writing a recursive formula, I thought it was getting dry. You have to determine whether it's arithmetic or geometric. Okay. Some of you will be able to just look at it and pick up on the pattern right away. But start with what we did yesterday when we were determining is it geometric or is it not. Where we take the ratios of all of them. So starting off with 48 over 16. What's that? 3. Okay. 144 divided by 48. Sorry. 3. So far so good. 4 into 32 divided by 144. 3. So which type is it?
Geometric.
Geometric. Now if you're getting different things, it probably means it's arithmetic, but that means you need to take the difference. You need to subtract the 2 to make sure that they're the same. Okay. So this is geometric, which means we're using the geometric recursive sequence. So we need to know first term, which is what? 16. Okay. So our first term is 16, which you will list as a part of your answer. That's the first part. Okay. Now we need R. It's the common ratio of 3. Okay. So we already know R is 3. So you need that information anyway. All right. So to figure out whether it's geometric or not. So looking up at example 2, since that one's geometric, we're going to write the same thing. Okay. So for example 2, it starts off with, I'm just going to switch colors here. First term is 16, and, or if you just put a comma there, that's fine. A sub n equals what? It's in the chart right above this. What's your R value? 3. And then times A sub n minus 1. Now is that the same formula we use on example 2? Yeah, but we have a different first term. That's the only difference. And then just put a comma and is greater than or equal to 2. Again, just a technicality, but you do need to include it.
Wait, we need to write all of that?
Yeah.
Okay.
So this is your answer. First term is this because you need to know where you're starting if you were to do the sequence without knowing that. So it's the same information that we started with on example 2. First term, here's your formula, and has to be at least 2 is what it's telling you. Because 1 is already taken care of.
So we're not splitting it?
No, the sequence is already there. So this is just the reverse of what we did on 1 and 2. You're taking the sequence and writing the recursive formula. Okay. Don't overthink it. Okay. You need your first term, common ratio, or if it's arithmetic, you need the first term and a common difference. Either or. Okay. Now, again, geometric is going to be multiplying or dividing. If I were to divide 9,000 by 100, what's that? 9. Is 9,000 times 9 17,000?
No.
No. So you could check based off a pattern. So this is not going to be geometric, but you need to know what your common difference is anyway. So we would do, as soon as you figure out it's not geometric, it's going to be arithmetic, the other type. But you still need to know what the difference is. So instead, you're going to subtract instead of divide as soon as you figure that out. Okay. So pick one of the two to test. Okay. So what's 9,000 minus 100?
8,900.
We have to make sure it matches. So what's 17,900 minus 9,000?
8,900.
Okay. And 26,800 minus 17,900.
8,900.
So this is what an arithmetic one looks like. Okay. Now instead of 8,900 being the R value, it's, in this case, D up here. Okay. So this number, that's our common difference, D. If that is positive, so it's increasing as we go through the sequence, that is going to just be plus that value. If it was subtracting, so it's getting smaller, then you just put a negative on that. Okay. Wrap it up. This is taking forever. I'm being distracted. Anyone tell me what the answer is? Written the same way the other one is. First term is 100. That's the arithmetic one in that chart list. We A sub n minus 1 plus 8,900, and then you also just have to tack on n is greater than or equal to 2. Okay.
So we don't have to include the, oh, wait, A equals, oh, the A1 equals 100
It's this
is
one
a
up
part
here.
of our answer?
What?
The A1 equals 100 is a part of our answer?
Yeah, because you have to describe where the sequence is starting.
Okay.
Okay.
And
It's just writing it,
what's N?
any number, any term. So if I were to plug a 2 in here, I would get 100 from the first term plus 8,900, which is 9,000. So it's a formula for how to find any of these. It's just recursive based on the previous term. Yeah.
I don't get how you got 8,900, because isn't it 17,900 minus 9,000?
Mm-hmm.
Isn't that like, it's not 8,900, right?
Whoops.
Oh.
Let me do. Whoop. Well, it went to me. 8,900. Which you put the right number of zeros in. So the difference between all those is 8,900. So it's increasing by 8,900. So since it's adding or subtracting, that is the arithmetic one. Multiplying or dividing, geometric. Questions? We're gonna do it again. Just given to us differently in this one.
Why is there a graph?
Because this is technically how it's linked.
What is going on?
Now, you guys see on the coordinates, so we're gonna write a formula for this. See how it says 1, 2, 3, 4? That's the order of the sequence. This is first term, second term, third term, fourth. So all you're looking at is the y values. Okay. So if you're given a graph, just list the y values in order. So it'd be 109, 84, 59, and 34.
Is it different?
Okay.
Oh, so different.
Now, just looking at it, do you think it's arithmetic or geometric? Just looking at it, what would tell you?
Because it's big number, small number, big number, small number. See how it's fees.
Well, it's decreasing.
There's no big jump in 84
So just the list of numbers, if you do 109 over 84, that's going to be a weird fraction. This is also going to be a weird fraction, and it's likely not the same. Now, should you test it just to make sure? Yeah. Now, since we have a picture, if I were to connect the points, what shape would it make?
A line.
What kind of line?
linear.
Straight,
Yes.
which is linear, which is arithmetic. It's a constant relationship.
Uh-huh.
If it's multiplying, that would be our exponential graphs, which curve. Okay. So if you have the visual, that is a straight line. So that is arithmetic. So I gave you a graph one because you might be given a graph sometimes. So you can go off the shape of it to help you draw that conclusion too. All right. Now what is it decreasing by? It's subtracting 25. But if you took your common difference of all of these, it'd be negative 25. If you started dividing them, like 84 divided by 109, weird decimal or a fraction, and then it was 59 divided by 84, not the same. Okay, so you could check it just to be sure, but this one is arithmetic because of the common difference. Now negative 25 is your common difference value D, okay. And 109 is your first term. So these are the two pieces of information you need. Okay. So this would be first term, A1 is 109. And our formula for recursive would be A n minus 1, which is previous term, minus 25, since it's a negative 25. And then just put a comma, and it has to be greater than or equal to 2, just meaning we don't want a 0 or there's no such thing as a negative term of a sequence. Like we can't go, what's the negative 5th term of the sequence? Doesn't work that way. Okay. Lily.
You do a comma between A1 equals -5 and
Where?
like instead of and, you said.
Oh, instead of this?
comma.
You can do a comma, yeah. Just make sure you leave some space a little bit, just so you know this is separate from that. It's just a piece of information you need, if that was all you're given. So you might be given a picture sometimes. If it is linear, that is arithmetic. If it curves, that would be a geometric. Okay. Questions before we do the last one? Which is given to you yet a different way. It's in a table. Same deal as if it was on a graph. Okay. So the premise of a movie is that a new virus is spreading, turning infected persons to zombie-like creatures. There's been a lot of movies like that. table outlines total number of infected persons at the end of each day. Write a recursive formula for the sequence, then also write an explicit, so there's both. Okay, which is why I wrote the explicit on the other side of your notes. So you need to write both, or it might say write an explicit formula for your nth term. Just keep that in mind. Okay. Now, is this going to be arithmetic or geometric, do we think? How do we know that?
Because the numbers.
They're making huge jumps, okay? So that would imply that there's multiplication involved, not just adding. Okay. It is increasing, but we're gonna have to multiply. Can you guys tell me what the common ratio is?
4.
It is 4. Okay. So this increase would be times 4. When we started this unit, we started with tables, and I said, is this exponential or linear? Same deal with the sequences. Okay. So since it's multiplying, that is a common ratio. So these are all times 4. Okay. So keep that in mind too. All right. So this would be this would be exponential growth in that case. So your R value is 4. Okay. Your first term,
12. Or 3.
3. The recursive formula for geometric. Okay. So the recursive, so if you want to, actually, I shouldn't use an R. So we have, what the heck? Okay. Recursive is the a sub n equals R times a sub n minus 1. Okay, so this is in the chart that's on the front. Your explicit one from yesterday was what?
N equals A1 times R n minus 1.
So since this one is asking for both, you will need to fill out both. Okay. Sometimes it's just recursive, sometimes it's explicit. Okay. So this is define any term as long as you know the first term, and this is a lot faster. So this is like for the 100th term. Recursive one, if I wanted to know the 100th term, I would have to know the 99th term, which means I would have to know the 98th term. So the recursive one is really just finding each individual term based on the previous one. This is to find anything no matter what, because you put the first term in the formula. And that might be a little confusing, but that's the difference between the two. So this is any term. This one you have to know the previous term. So it's not as simple. So you can't just find the 100th term on the recursive. You would have to know the 99th, the 98th, the 97th, and so on. So, anyone tell me what the recursive one, which is what our focus was on today.
A1 equals 3 and AN equals 4 A minus 1.
And then just tack on n has to be greater than or equal to 2. So this is your recursive one. And yes, all that information has to be included. What's the explicit one?
A of n equals 3 times 4 to the power of n minus 1.
So the explicits we learned yesterday a little bit easier. Yes, and this is to find any term. Okay. This is telling you could find any term, but you would have to go in order to get there. Okay, which would be way more time consuming. But you do need to be able to use both. Okay. So, what questions do we have for me? I will provide both formulas on a test. Actually, also the arithmetic one. But you need to know which one is used for what. Okay, which is going to take a little bit of practice. So, your book assignments, 1 through 11 odd. So it's on page 535. That's the wrong one. 1 through 11 odd, that is 5 problems. No, 6 problems. 12 through 15 all, that is 4 more. 19 and 20. So there's 12. Okay. They're all pretty similar to our examples, so maybe have your notes out. At least have these 2 formulas, because you probably have to use both at some point. Okay. If you have 15 minutes, you can probably get a good chunk of those 12 problems done. Okay.